I'm going to talk to you about how you can customize generative AI with your own private data. Before we do that, I first introduce how actually public data makes its way towards generative AI, or more specifically towards your generative AI solutions that you're building. So public data is, of course, massive amount of data. It's actually the whole internet, right, that is out there. And that actually is being used today to train models for generative AI. In order to do that, the first step that happens is data is prepared. So there's some data prep happening to make it ready for training as a next step of a so-called large language model, LLM. So because we are now talking about here a large language model that is trained on public data, that anybody can get access to and anybody can use it, this is now a generic LLM that basically can serve all kinds of purposes. So this model is trained and it exists, and then you can use it in a so-called prompt to generate some output. For instance, in a GPT solution, right, that's the thing that's happening. There's a generic large language model, and that's why we can also call this is a generic prompt. So the thing is, we're talking about here massive amounts of data, right? The whole internet, right? That's what we're talking about. That's why this whole process, this whole thing is terribly expensive. It's terribly long lasting, right? We are talking about really farms of thousands of GPUs being used for days and weeks in a row for a single model training. For that reason, at least for the very large models that are out there today, for that reason, this is commercial business on its own. This whole thing is a commercial business, and there are commercial vendors out there that are making money exactly with that, making these generic models available. But there are also open initiatives, open ecosystem, and that has evolved for basically providing this also for free, for instance, on Hugging Face as the most popular platform that you find out there. So this is just as a baseline how you basically can do generative AI in a generic way with models off the shelf, so to speak, that you can just download or you can use at the commercial vendors as a service delivery. So next, let's talk about customization of the whole process. And customization means customizing it with your own private data. Could also be really just domain-specific data. But let's assume you have your own private data corpus that is not available to be trained by any commercial vendor publicly. How do you get this into a generative AI solution? Well, the first thing is you have the data again, you need to prepare it. So this is very similar to the process above. There are some data preparations that need to go on. Many things could be said. It's not the subject for this video to go in detail here what this means. Once we have the data prepared, there are now two fundamental paths how you can get it to customization. The first path is you again do a training. You train this model on this data, but you don't train it from scratch. You train it by using an existing generic large language model, and you're extending it. You're training additional information into the existing model. For that reason, this is also not just called training, it's called fine-tuning. So you're fine-tuning an existing generic model with your private data that you have prepared. What you then can get is your custom model. In the case of text data, we're talking about a large language model. Right? And then you can take this custom model and you can also prompt it. Same way as above here, but this is now a custom prompt because it's using a custom model. So that's one way of doing this whole thing. The problem with that is that it still means you need to train. And that training is same kind of training here, not as massive, but still requires GPUs and it requires time. So it is a problem in terms of cost that you need to spend each time you want to update this model. You need to run this fine-tuning again, and it takes time. So when new data arrives, you first have to do that before this data is available to a generative AI solution. So it's not necessarily real time what we're talking about here in terms of new data arriving and in the consumption of that data. That's why there's another alternative to achieve this goal here. And this is by taking this prepared data, not in a training step, but consuming it at runtime with the prompt. For that reason, you compute for these private data, you compute the so-called embeddings or vector embeddings. and you put these vector embeddings into a vector store. Right? And the reason for that is that this vector store is now an optimized way to retrieve very efficiently and interactively the matching private data that matters for a certain prompt that you're doing. Now you can now go and you can say, okay, I have my private data vectorized. I have made it retrievable in a very interactive way. So I can just augment, I can just retrieve it interactively when I'm prompting this model here and augment this prompt with my private data. So I'm retrieving this data interactively, I'm augmenting it, and then I'm prompting in order to generate an output. That's why this whole thing is called Retrieval Augmented Generation, RAG, or short RAG. Right? This is now the way for you to say, okay, even though this data is constantly changing, I'm just taking care that this embedding is always up to date in my vector store, and anytime I can prompting now my generic model, I get the latest and up-to-date data augmented into my prompt. Right? So you don't have to do all of this in order to wait for this new data to be trained or fine-tuned into your own model. Now, of course, this is not always an either-or. You could, of course, also combine this. You could say, you know what? I'm doing that, right? I'm taking my custom model, where I have trained some amount of data in a fine-tuning fashion, and the very latest data